Everyone, welcome back from spring break, whatever it was, and here we go. We're starting into term 4. Remember that term 4 is going to count all this virtual school stuff that we're doing, whether we go back to school or whether we stay away. This counts for a grade, so please make sure you take this stuff seriously and get it down. And of course, always if you have questions, please post them to Schoology on our updates page, or you can message me too. All right, so let's get into things here. Our new unit is going to be talking about square roots and cube roots, and so we'll get right into things here. So the way we kind of think about or first introduce the idea of a square root is that we talk about inverses of quadratic functions. Okay, remember quadratic functions was something that we talked about in our second unit, right? A quadratic function is a parabola. Okay, it looks like, that. All right, and we're going to talk about the inverse of that, what the function is that undoes a quadratic. So if you remember, to find an inverse, we swap x and y, and then solve for y. And that allows us to find our inverse. Okay, so here's our function right here, and we're just going to then rewrite this as y equals 3x squared. Okay, and then we will swap the x's and the y's. So now we get x equals 3y squared. And then we're just going to solve for y. So the first thing we're going to do here should be, to solve for y, to get that y by itself should be what? Hopefully you said divide both sides by 3. And so we're going to divide both sides by 3 here. 3's cancel, and so we'll just have x over 3 equals y squared. Or you could think of it as 1/3 x equals y squared. Okay, because there's really like a 1 in front of that x there. Right? And then from here, what's our last thing we want to do to get the y by itself? Well, we want to get rid of this square right here. How do you get rid of a square? And the answer is you use a square root. So we square root both sides here. So we get y equals the square root of 1/3x, just like that. Now, in an equation setting, we should technically put a plus or minus there in front, just like that. Okay? Now, if we go to our graphing calculators and take a look at this, comparing the graph of y equals 3x squared and the graph of y equals plus or minus 1/3 x, we do run into something a little bit funky here. I'll just show that to you real quick. So let me change over to our graphing calculator. Okay, so I know that this might change your orientation. Hopefully you guys can still see this stuff okay. But we'll go to y equals here, clear out the stuff from before. All right, and I'll type in 3x squared. And then also the square root. So second x squared gives you the square root command, second and then x squared. And then it'll be 1/3 and then x. Like that. Okay, if we graph, there is the original quadratic, and there is our square root. But you'll notice I have to graph plus or minus this square root of 1/3 x. So I'm going to also type in a negative square root here of 1/3x. Okay, to get that graphed here. Whoops, I wanted the x to be inside there, so let me squeeze it in. There we go. Okay, now I'll graph it. Okay, it might be a little bit hard to see here, but if I press zoom and then square, that will, number 5, that'll help adjust kind of our window here to see what I'm talking about. And you can see here that the quadratic that we originally graphed right over here, okay, the original quadratic, and then the inverse, the square root function right there, the plus or minus version, you'll see they are exact reflections of each other. And in fact, if I graph a fourth thing here, I'm going to graph the line y equals x, which is just that diagonal line that goes through the x-axis. You can see we have a line of reflection there. So a function and its inverse, in general, the function is the reflection of the inverse over this line y equals x right here that I graphed. Okay, and then the inverse is also the reflection of the function over the line y equals x. So they're both reflections of each other over the line y equals x. Okay, just a little geometry, tidbit there for you. All right, so of course we can use our graphing calculators to help us graph this stuff too. All right, let's go back to what we were talking about here. Oh dear. Okay, so now what we will take a look at then is just another problem here to find the inverse of. All right, so here's another inverse for us to find. We have f of x equals x squared minus 7, so I'll change that to y equals x squared minus 7 and swap the x and y. So I'll get x equals y squared minus 7. Here, what should be my next step to get the y by itself? What do you think? All right, hopefully you said add 7 to both sides here to get that 7 over first. Then we'll square root both sides. Okay, the square root typically is going to be like the last thing you want to undo, or at least, you want to get rid of everything else. You want to isolate that square first. Isolate the squared term before you square root. This is going to be a good idea in general for what we're going to be doing in this class, for this unit. Okay, so anyway, we square rooted both sides here. We square rooted both sides here, and so we're going to end up with y, right? Because square root of y squared is just y. And then the square root of x plus 7, that doesn't really simplify, so we'll just leave it as the square root of x plus 7, like so. Okay, and again, because we're in an equation setting, I should put a plus or minus there. All right, and so there's the inverse. If you want to, you can go one more step further, put the actual like f inverse of x like that, and then just, again, write plus or minus x plus 7, but there's the inverse right there. Okay, now your homework's going to ask you to do stuff with domain. I'm not going to have you guys worry about that. We're just going to stick to just finding the inverse itself. So your homework's going to have questions like these. Don't worry about finding the domain, and I'll note that in the homework assignment itself. The other thing I wanted to show you guys today was graphing square root functions as well. And we're going to start with our parent function here, just the basic square root of x function, okay? And I am going to have us see what that parent function looks like, and then we'll talk about the different transformations. You guys kind of get a little sneak preview right down here of stuff we've seen before. I told you we were going to be seeing every single unit, so no exception here. Anyway, so the square root of x, you'll notice I set up a table here, which is very common, again, for all the graphs we've been doing here. You, of course, will be able to use your graphing calculator for any of this stuff, but, I wanted to help you out at least with the table because it's helpful just to organize your work, see it there. Anyway, you'll notice here that the x values that I picked, though, are a little bit different. First of all, you'll see that I didn't pick any negative x values. And that's because what happens if I were to put a negative x value in here? What is the square root of a negative number? Okay, hopefully you remember from our previous unit, right, that square roots of negative numbers are imaginary, right? The square root of like -2 is imaginary. We don't want to take the square root of negative numbers here. We want only real, okay? For this unit and for everything else after here, we're pretty much going to stick with just real numbers, so anything that ends up with an imaginary root is not going to be helpful. So we're going to kind of like not worry about it, or an imaginary answer. So that's why I start here with just 0, because you can take the square root of 0. Okay, 0 is a perfect square. The square root of 0 is, well, it's 0. So we can just put that in there. In fact, you know what? I'll use red here just to kind of make it stand out a little bit more. Okay, now I also then went to 1 because it's like, okay, well, 0, we can just do 1. Square root of 1 is easy, it's 1. You'll notice I did not put 2 or 3 in here on my table, and the reason for that is because imagine plugging 2 or plugging 3 in here. Do you know what the square root of 2 is? Do you know what the square root of 3 is? If you don't, type it in your calculator. When you type it in, you're going to see that you get like a really long decimal. In fact, that decimal goes on forever and never really repeats regularly, and that's why we don't really use it, because it's kind of hard to graph that. You could use it if you wanted to, but I would really like us to focus on these nice numbers here. So we skip 2 and 3 because they're not perfect squares, and we go to 4. Now we know what the square root of 4 is. The square root of 4 should be 2, right? So, and then same thing, that's why we don't pick 5, 6, 7, or 8. Those are not perfect squares, but 9 is another perfect square, and we get then a square root of 9 is 3 when I plug those in. Okay, and again, all I'm doing here, I'm just taking these x values here, okay, and I'm plugging them in to this function right here. Okay, that's it. And now we have some coordinates we can graph, right? So I graph the point 0, 0, graph the point 1, 1, graph the point 4, 2, and 9, 3. And we connect the dots. Okay, you can see your graph here. Notice that our graph has a starting point or a stopping point, right? It does not go forever to the left here. Excuse me, it starts at 0. So our domain then here, okay, it's going to start, what's the farthest left that we go? Well, if you look at the graph, right, the farthest left we go is 0. And what's the farthest right that we go? Well, the farthest right, we have an arrow there. So what's the farthest right? Infinity. We do get to the 0, so we're going to include the 0 square bracket, and we never can get to infinity, so round parenthesis there. All right, then for the range, you know, describes the y values, right? And so what's the lowest y value you see here? Well, again, it's that 0, 0 point right there, so it starts at 0. And what's the highest y value? Well, you can see this arrow here. It's not only going to the right, it's also going, you know, up more too. Not quite at that pace, but I mean, it's still increasing everywhere. And so we're also going to go to infinity as well. So the domain and range are both 0 included to infinity excluded. Okay, and of course you can use your graphing calculators. You can type this into your y equals on your graphing calculators and get, you know, a nice graph of that to help you then, you know, figure out what the table is by going to your table and then graphing this on your paper right here. Okay, of course transformations, same stuff we've seen before, right? So this minus h that's in with the x is going to shift things left and right. Okay, if we subtract a positive number, that means you're going to shift right h units. And if we subtract a negative number, we're going to shift left 8 units, h units, I mean. Okay, for the k here on the outside, remember that shifts things what directions? Okay, yeah, we're going to go up k units if k is positive, and we'll go down k units if k is negative. Oops, I don't need to put that there. Okay, and then the a, what's that do? Same thing it's always done, vertical stretch or shrink. So if a is bigger than 1, it's going to be stretch. If a is between 0 and 1, so like 1/2 or 1/3 or 3/4, that's going to be a shrink. A vertical, these are all vertical stretch. Vertical shrink. Excuse me, and if a is less than 0, remember that what that does? Reflect over x-axis. Okay, so let's take a look at an example here. All right, so here's our function. All right, we can see that our h is a -3, our k is a -2, and then our a is a 2. So what is our transformation going to be? We're going to be shifted right 3 from that h. We're going to be shifted down 2 because of the k. And then for the a, what's that positive 2 going to do? Stretch, whoops, can't spell, by 2. Okay? So, if we go back up here to our parent function, remember that 0, 0? That 0, 0 is going to be like our vertex or like our center point that we've talked about before. That's our special point that we're going to transform. Okay? So 0, 0, it's going to transform, and it's shifted right 3 and down 2. So if we're going right 3 and down 2, that means we're going to go right 3 to 3 and down 2 to -2. Excuse me, just like that. So that's going to be our new special center point, and so you can create a little table here. Okay. Now, originally, our special point started at 0, right? But then it had to transform to be 3. Our next special point was 1, then 4, and then 9. Okay, so if 0 transformed to 3, it means it moved right 3. This other special point of 1, okay, it's got to transform right 3 to be 4. And then 4, which again was our special, you know, another special point that we use in our table up here, right? There's that 4. Okay, it's also going to transform shift right 3 to become a 7. And that 9, again, we had 9, right, on our original parent function here. That, however, had to shift right as well, shift right 3, so that's now at 12. Okay, and so we're going to plug 4, 7, and 12 into our function here. Okay, and when you plug those into the function, or again, you can go to your table. In fact, let's go ahead and go to our table. So 2 root x minus 3 minus 2. Okay, so 2 square root x minus 3 minus 2. Oops, I wanted to clear that one out too. Okay, so we go to our table, second graph. You can see there's those errors, right, for the negative x values. Okay. There's our special point at 3, -2, right? Then at 4, 0. 5 is no good, 6 is no good. You can see you get these like crazy long big decimals there. There's 7. 7 gives us 2. So 7, 2. 8, 9, 10 doesn't work, and then 12, 4. So 7, 2, 12, 4. And we'll go back to our notes here. 7, 2, 12, 4, and 4 was... what was 4? Shoot, well, let's see here. I'll just plug it in. 4 minus 3 is 1, square root of 1 is 1, times 2 is 2, minus 2 is 0. So there we go. So negative 2, 0, 2, and 4. Okay, so we can graph this. All right, so let's see here. I'll count by 2. So 2, 4, 6, 8, 10, 12. And I'll count by 2's here, 2. So 2, that's negative 2, 2, 4. Okay, great. We'll just plot our points. So here's 3 right here, negative 2. That means the point would go right there. Okay, and then 4, 0 would be right here. And then 7, 2 would be right here. And then 12, 4 would be right there. Okay, and then we just connect the dots. Okay, we will extend in this direction, but remember, do not extend in that direction. That's our starting point, so that's where we stop, right there. Okay, and so there's how you graph. Again, use your graphing calculators to help you get some nice points from this graph if you want to. Remember to first, use your transformations, right? Transform 3 to the right and down 2 to get that nice center point right there. All right, I'll do one more for us here. So again, what kind of transformations do we see here? Well, we're going to be shifting right 2 because of that minus 2 right there. Okay, we're going to be shifting up 3. Okay, because of that k. And then we have a negative 3 in front, which indicates, oops, let me do it this way. We're going to be stretching by 3, but it's negative, so we're also going to be reflecting over the x-axis. Okay, and so what's our table going to look like? Well, again, the normal starting point of our graph here is going to be at 0, 0. Okay, since we shifted right 2 and up 3, where is that 0, 0 now going to be? Well, right 2, it means it's going to have an x-coordinate now of 2. Up 3 means it's now going to have a y-coordinate of 3. Okay, so when I go to make my little table here, okay, 2, 3 will be my starting point. And again, that's like the 2 is like my 0. Okay, and then I had 1, then I had 4, and then I had 9 as those normal points. Again, back up in my parent function, right? 0, 1, 4, and 9 are the x-coordinates we used. But with transformations, right, that 0 became a 2, shifted right 2. So what will 1 become? Well, it's going to shift right as 2 as well to become a 3. And 4 will shift right 2 as well to become a 6, and 9 will shift right 2 again to become an 11. All right, if that is a little confusing to you, remember you can always fall back on your graphing calculator. You can type this whole mess in your y equals, and then go to the table, and these points will naturally kind of show up for you because they'll be the ones that give you nice numbers, nice y values that correspond with them. And I'll show you that here once we're done. All right, these notes will be a little bit longer. Okay, so again, you can plug, whoops, not plug 1 in. You can plug 3 into the function here. Okay, so you can plug this 3 over here in for the x and then simplify this. Or you can just, again, go to your graphing calculator. So we'll do that. So negative 3 root x minus 2 plus 3. So negative 3 root x minus 2. And don't forget to arrow out, so you can do that plus 3 on the outside. If you have an older calculator, make sure you close the parenthesis here with the square root and stuff like that. Okay, go to graph. There's what our graph looks like. You can see the reflection there, right? And so we'll go to our points. Okay, so there's 2, 3. That's the 0 that we got. So it's 3, 0, 6, negative 3, and then 11, negative 6. Okay, so 0, negative 3, negative 6 are the matching y values there from our graphing calculator. Okay, and so then we plot these points, and then we'll finish our graph. Oops, actually I'm going the wrong direction here. I need to move my x-axis up more into the middle because I am going to start with some positive values, but then I go to negative values in the y. So I need to have some negative and positive y values. So I'll count by 2s again for the y's. So 2, 4, 6, and -2, -4, -6. Okay, and we'll count by 3s, or no, I'll count by 2s of the x's too. So 2, 4, 6, 8, 10, 12. And I'll go ahead and just change the color up here just to kind of make it more interesting. Use green. So plot the points. So our first point here is 2, 3. So 2, 3, there it is. And then 3, 0, which is right here. And then 6, -3 is right there. And then 11, -6 will be like right there. And again, just start here with that's our starting point, right? That's where that 2, 3, right there. So we'll start here and then just connect the dots on through. And again, draw an arrow. Do not draw an arrow here, right? It starts there. And there's your graph. All right, so homework assignment will be posted for you, and then go ahead and practice some of those. Let me know if you guys have any questions.